Hello, dear students. Welcome back to the lecture series on this major theory with course code MMTC 202. Today, in this lecture, we will discuss simple and step functions, and we will also see some. We will also discuss some certain properties of these functions. So these functions are actually the tools for the measurable functions, for the integrable functions actually. So let's first discuss these functions. So in order to define simple function, we first need to define characteristic function. Okay. So given a set x, let x be a given set. Let x be a set, be a given set, be a given set, and this A, it is subset of X. Then the characteristic function of A, characteristic function of A, which we will denote by chi of A, is a function from X to R defined by chi A of X is equal to 1, chi A of X is equal to 1 if X belongs to A, and its value is 0 if X is not in A, if X belongs to A component. Okay. So the characteristic function of A, the function chi of A is also called the indicator function of A. The function A, the function chi of A, chi of A, the function chi of A, so let me first erase this. The function chi of A is also called the indicator function of A. The indicator function of A. The indicator function of A, and is also denoted by IA. So that is the definition of characteristic function of A. Now we have some properties of the characteristic function of A. For any subsets A and B of X, for any two subsets A, comma B of X, the following hold. First one, characteristic function of empty set is 0 and characteristic function of whole space is equal to 1. Second property is A substar B implies A substar B implies chi A is less or equal to chi B. Chi A less or equal to chi B means chi A of X is less or equal to chi B of X for each XD. It's actually point-wise lesser equality for each x in x, chi a of x lesser equal to chi b of x. That's what do we mean by this chi a lesser equal to chi b. Third property is chi of the intersection. Chi of the intersection is equal to the product of the characteristic function, and it's also equal to the meet of these two functions. Fourth property is chi of union. Chi of A union B is equal to chi of A plus chi of B minus chi of A intersection B, and it's also equal to the join of chi A and chi B. Join of chi A, chi B. And the last property is the chi of difference. Chi of A minus B, it's equal to chi of A minus chi of B, chi of A minus chi of, sorry, it's chi of A minus chi of A intersection B. Chi of A minus chi of A intersection B. Chi of A minus chi of A intersection B. And the last property is chi of, if A is a disjoint union, that's the sixth property. If A is equal to the union A and n runs from 1 to infinity, where these AIs, they are all subsets of X, and AI intersection AJ is phi with 1 less or equal to I comma j less or equal to n, and I is not equal to j. So then if A is this union, then chi of this A, chi of the union is equal to summation chi of A n runs from 1 to infinity. So these are the properties of the characteristic function. So let's prove these properties. Property 1 is trivial. I will not discuss that property. Prove. First property, it's trivial. It's trivial. Because characteristic function has only two values, 0 or 1, and chi of phi must, so obviously it's equal to 0, because there is no point in phi where it will take the value 1. And chi of x, chi of whole space must be equal to 1, because there is no any other point outside of x, because x is the whole space, and chi of x must be equal to 1 for each x, it's equal to 1. So that's trivial. That's trivial. Now second property, suppose A is subset of B. We show that chi A is less or equal to chi of B. So I will discuss certain cases here to prove this part. Case 1. If x belongs to A, but A is subset of B, this implies x is also in this set P. So therefore, chi ax, it's equal to 1 because x is in A, and it's also equal to chi bx because x is also in B. So that means chi A is equal to chi B in this case. Chi A is equal to chi B. Case second. Case second. If X belongs to B, but X is not in A, then what is chi A of X? Chi A of X is equal to 0, which is strictly less than 1, where 1 is equal to chi B of X, where 1 is equal to chi B of X. So therefore, in this case, chi A is strictly less than chi B. And last case, if X is neither in A nor in B. Case third, if X does not belongs to A and X does not belongs to B. X is not in A, not in B. X does not belongs to A and X does not belongs to B. Then chi AX is equal to 0, which is equal to chi BX. So therefore, chi A is equal to chi B. So thus we have seen that either chi A is equal to chi B or chi A is strictly less than chi B. So thus we have to follow. Thus chi A is less or equal to chi B. That's the second part, second property of the characteristic function. Now we discuss the third property of the characteristic function. Okay, third property. Third properties. What's third property? Chi of A intersection B is equal to chi A into chi B, and it's equal to the meet of chi A and chi B. Again, I will discuss certain cases here for part third. So case 1. If X is in this intersection, if X, either X belongs to the intersection or X is outside of this intersection. So first case, if X belongs to the intersection, this means X is in A as well as in B, and X belongs to B. So now let's find the values. Now what's chi A intersection B of X? It's equal to 1. And what's chi AX into chi BX? Since X is in A as well as in B, so both the values are equal to 1 actually. So they are 1, it's 1 into 1, which is equal to 1. So thus chi A intersection B of X is equal to chi A of X into chi B of X. This is a comma here. So that implies, this gives chi of A intersection B is equal to chi A into chi B in this case. Similarly, you can prove that this is equal to chi A meet chi B. That you will do yourself. Now we'll discuss this case second. What's case second? Case second is if X is not in the intersection, if X does not belongs to A intersection B, this implies X does not belongs to A this implies X does not belongs to A or X does not belongs to B because it's not in the intersection. I will erase this here. Okay. X does not belongs to A or X does not belongs to B. Okay. So then what's this? What will be this chi of A intersection B of X? It's equal to 0. And chi A of X into chi B of X, it's equal to 0 because either X is not in A or X is not in B. If X is not in A but in B, then at that time this will be 0 and this will be 1. Therefore, it's equal to 0 into 1, which is equal to 0. And second case maybe like this: X is not in B but x is in A, then in that case this will be 0 chi B of x, and this chi A of x will be equal to 1. It's again 0 into 1. And the third case, if it's neither in A nor in B, then it will be 0 into 0, that's equal to 0. So in all these cases, it's equal to 0. So thus they are equal, both are equal to 0. Thus chi of A intersection B is equal to chi A into chi B in this case also. So in both the cases, so hence this holds chi of A intersection B is equal to chi of A into chi of B. Chi into chi B. So that proves the third property, and now we check the fourth property. Fourth property. Okay. Now we check the fourth property. What's fourth property? It is the chi of the union. Chi of A union B, it's equal to chi A plus chi B, chi A plus chi B minus chi of A intersection B, that's also equal to chi A join chi B, chi A join chi B. So I will check first and third are equal. Okay, I will check these two are equal. I will check these two are equal. I will check these two